Hi, I'm Wayne Jensen, and I'm grateful to be here and be able to help you navigate through the last half of your 370 class. We're here in lecture 61B, and my goal is to create lectures that are very similar to what you are used to with Professor Eitel. And so I looked at his videos and saw that he went over the notes that he did, and so that's what I'm gonna do here. Please let me know though if there's more that I can do. And so, as you know about angles, having taken the prerequisite for the course, what we're looking to do here is just make sure that we all have good trigonometry skills before entering into calculus. And so in 6.1a, we were describes angles and also degrees and radians and I'm sorry, measurements of angles in degrees and also radians. And so radians is really the angle of choice as you move into calculus, because in radian measure you have a real number equivalent. And so as we start out here, everything's in radians. And so we're going to start talking about reference angles. As you remember from your trigonometry course, everything's about a reference angle. We're going to memorize some very specific angles, 30 degrees, 45 degrees, 60 degrees, 90 degrees, or in radians, right? Pi over 6, pi over 4, pi over 3, and pi over 2. And if we get those first quadrant angles memorized, then we pretty much know everything because it's all repetition. And so it says, as we start out here, the reference angle is the angle, the terminal side of the angle of measure theta makes with the x-axis. And it's really important that we recognize that it is always this terminal side with the closest x-axis. So it's always with the x-axis. So step number one is to draw the angles of measure theta with the terminal side in the correct quadrant. So we got to choose the correct quadrant, and then we decide what the reference angle is. The reference angle is the angle of the terminal side makes with that x-axis. The reference angles will have a measure between 0 and 90 degrees, or between 0 and pi over 2. So if we continue down this this lecture, we come down and we say if an angle measures between 0 and pi over 2, the terminal side is in the first quadrant, the angle the terminal side makes with the x-axis will be the angle itself, theta, which is the same measure as the original angle. So hopefully if that makes sense, we can see that down here with example 1. The original angle is pi over 3. Well, pi over 3 is in that first quadrant, right? It's right here, coming right up along this side right here. And this is the original angle pi over 3, and the reference angle is also pi over 3. So it's not very exciting when it's in the first quadrant. So as we navigate down and maybe come to an angle that's in the second or third quadrant, let's look at example 3. So the example 3, right, which is right here, example 3 says if the original angle measures 2 pi over 3. Well, let's think about that. 2 pi over 3 is in the second quadrant because where's 2 pi over 3? Well, it is pi over 3 away from getting to 3 pi over 3. Because what's 3 pi over 3? It's pi. So we come in recognizing that this is 0. If we're talking in radians, this is pi. And we want to find out where we are. Remember, this is pi over 2 and this is 3 pi over 2. So when you have something like 2 pi over 3, like we're dealing with here in example 3, we know that it's closer to the negative x-axis. It's in the second quadrant. And so the reference angle that it makes is pi over 3. So even though we're dealing with the 2 pi over 3 angle, in fact, all of these are mistyped. These should be pi's. This might be very confusing to somebody. Those should all be pi's. Same thing over here. I'm not sure why he has thetas in here. These should all be pi's. So maybe it's good that we're going over these lecture notes together. Um, but they are not to pi yet. So whatever that base number is for 3, we're going to compare things to 3 pi over 3, 6 pi over 3, because we care only about the x-axis. And on the x-axis, we're either 0 pi or 2 pi, like you remember, or 3 pi, right, as we keep going around. So let me erase some stuff here. If we come back and look purely at example 4, if the original angle measures 3 pi over 4, well, where's 3 pi over 4? It's pretty close. That's what we're going to ask ourselves. Where's 3 pi over 4? Is it closer to pi, or is it closer to 0, or closer to pi? Well, maybe it's hard to tell, but our base angle is 4. This is 0 pi's over 4. And pi is 4 pi over 4. What's it closer to? It's closer to 4 pi over 4 because it's 3 pi over 4. How far is it back? It's back a pi over 4 measurement. So everything is related to the pi over 4 reference angle. And we do everything off of reference angles. If we go to the third side and we're looking at something like 4 pi over 3, like we are here in example 5, our question really is, are we closer to 0 or closer to pi? Well, it's 4 pi over 3, so I'm going to consider this as, 3 pi over 3, and 0 pi is over 3. What am I closer to? 4 pi over 3 is way closer to 3 pi over 3. How far is it off? Well, it's ahead of it by pi over 3. Does that make sense? So it's related to 3 pi over 3, and it takes an additional pi over 3 to get there. That's how I think about it. What he's saying here is you have 4, and these really should be pi's. Not sure why he has thetas here. Big mistype there. Where is 4 pi over 3? Well, it is pi over 3 back from pi, or I'm sorry, ahead of pi. That's how I would look at it. Same thing here. Where's 5 pi over 4? My thought is, if I'm considering 5 pi over 4, that is pi over 4 beyond pi. Because what's pi? Pi is 4 pi over 4. So we get a pi over 4 reference angle there. And so he continues by looking at something in the fourth quadrant. So that would be something good to look at. So what I'll do is I'll look at his 2 examples, and then we'll make up our own. So if we're considering 5 pi over 3, we got to get it in the right quadrant. So where is it? Is it in quadrant 1? No, because it's beyond 3 pi over 3, right? Because that's what this is. This is pi, or 3 pi over 3. Now, what's it really close to? Remember, this is 6 pi over 3 over here because it's 2 pi. It's really close to 6 pi over 3, right? We're looking at 5 pi over 3. How far is it away? Well, it's this distance away right here. Let me do that in the red color like he's doing. It's this distance right here. Now here he's got the right symbols in. Remember in the previous ones he was using thetas? He needs to be using pi's, and he is right here. So this is pi over 3. So that's why we're saying the reference angle is pi over 3. If we're looking at 7 pi over 4, go back to the blue. If we're looking at 7 pi over 4, well, it's way beyond 4 pi over 4. The question is, how close is it to 8 pi over 4? I'm skipping the y-axis because remember, everything's related to the x-axis. That's how we determine the terminal side. If we go back up and look at the original statement, and I think it's worth doing, or I wouldn't do this, everything's related to the x-axis. So I'm not really even considering what the measurement is on the y-axis because my closeness to the x-axis is going to tell me everything. So as we come in here and look at this guy right here, we are really, really close to this. Here we are at 7 pi over 4, and it's really close. Now, how close? Well, how close it is the reference angle. It takes me another pi over 4 to get from 7 pi's over 4 to 8 pi's over 4. Why do I consider 8 pi over 4? Because 8 pi over 4, and I'll go in a different color, is 2 pi. Remember, 4 pi over 4 is another way written as pi. Okay, so that's what we're looking at as we go there. So what would we deal with? Apologize. Let me switch over to the notes. So let's consider for a minute the angle let's consider for a moment the angle 5 pi over 6. Well, where is that? Well, I got to consider two things. Is it close to, and I would do them in order, is it close to 6 pi over 6? And I'd say, oh yeah, it's really close to 6 pi over 6, but it's not quite there yet. Where is it? Well, it's right next to it. And how far is it away? Actually, let me switch colors there to get everything the same. It is pi over 6 away. So this 6 pi over 6, I'm sorry, 5 pi over 6 measurement is really close to 6 pi over 6. The distance it is away is called the reference angle. So this is going to help us out in the next section, or possibly later on in this section, right? And so if I had something like 11 pi over 6, let's consider 11 pi over 6. I would still say, well, where is that? Well, it's beyond 0 degrees. Is it pi degrees away? Well, pi degrees away would be 6 pi over 6. Nope, it's beyond that. Then I would consider again the x-axis. So if I come back around to the x-axis, then I'm at 12 pi over 6. Now, how do I know it's 12 pi over 6? Because I know that this is 2 pi around. Now, this should all be super familiar from your previous experiences in trigonometry, from the prerequisite to the course. And we're just looking to reinforce that. This 11 pi over 6 is really close to 12 pi over 6. How far is it away? Well, whatever that distance is your reference angle. It's a pi over 6 reference angle in that fourth quadrant. And so we're going to talk like that in future sections. We're going to talk about the reference angles as well. Let's see what's next. What's next is dealing with 90-degree angles. And whether you're closer to 5 pi, or whether you're related to pi over 2 or 3 pi over 2. I think these are the easiest ones. I'm not quite sure why we're going into so much detail as we go around, but let's see what we got here. If we look at example 1, the original angle measures 5 pi over 2. So we're reading that one right there, this example 1. So he's suggesting to take off however many pi's you need, and that's really good. You could subtract away 2 pi to see where you're at. You're definitely beyond 2 pi. And when you do, you realize, oh, you're at the pi over 2 reference angle. And so you know that your terminal side is right here, right? You're just basically trying to find that terminal side. 9 pi over 2. Well, if you're looking at 9 pi over 2, and if you're wondering, well, how do you know how many pi's to subtract? You're always going to subtract an even amount of pi's. Right? That's what this part right here is saying. So you could go ahead and try to subtract away 2 pi. Now what would 2 pi be? That would be 8 pi over 2 minus 2 pi's would be 4 pi over 2. And you'd be left with, oh, apologize, we had to start out with 9 pi over 2. Apologize. 9 pi over 2 minus 4 pi over 2. That would be 5 pi over 2. Well, that's still too big. We're looking to get it to either be pi over 2, which we know where it is, or 3 pi over 2. So we got to subtract away another 2 pi. And what's 2 pi? Well, 2 pi is 4 pi over 2. And so no matter how you do it, you can come up with a pi over 2 reference angle. The other way to do it is to take a look at something like 9 pi over 2. If I give you another way, a more intuitive way, and again, we don't want to destroy anything you learned in your trig class. So how I would do this is I would say, what's the closest even number? The closest even number to 9 pi over 2 is, let me erase what I put out there. The closest even number to 9 pi over 2 is 8 pi over 2. And what we are is an additional pi over 2 beyond that. Well, where is 8 pi over 2? Well, 8 pi over 2 is 4 pi. And we know that this is 0 and this is 2 pi, right? This is pi, this is 2 pi, this is 3 pi, this is 4 pi. And so that's 4 pi, so we know we're pi over 2 beyond that. Of course we are right here on our terminal side, and we have a pi over 2 reference angle. And so he's doing the same thing here with 3 pi over 2 reference angles, but let's try our trick again. Let's take something like they have in example 4, right? And in example 4, they're dealing with 11 pi. Whoops. They're dealing with 11 pi over 2. Let's try my technique. The closest is 10 pi over 2. And if we look at 10 pi over 2, well, what's that? 10 pi over 2, so this is 10 pi over 2, let me be careful here, plus another pi over 2. So we could be tempted to say that it's pi over 2, but remember, we have to consider what 10 pi over 2 is. 10 pi over 2 is 5 pi plus pi over 2. Well, where is 5 pi? This is 0, this is pi, this is 2 pi, this is 3 pi, this is 4 pi, this is 5 pi. Remember, all your odd pi's are on the left-hand side. They make the negative x-axis. All your even ones make the positive x-axis. So we are, if we consider this, here is where 5 pi over 2 is, and we are pi over 2 beyond that. So where are we? We are ending up, and I'll put it in red, right here with a reference angle of 3 pi over 2. Another way to think about that. So what he's doing here is he's seeing, subtracting away the 2 pi from it, or subtracting away the 4 pi. So you can always subtract away even pi's, and you're trying to get down to either pi over 2 or 3 pi over 2. So take your pick, whether you want to do what I showed you here is go into the closest even number pi, or if you want to go to subtracting the pi over 2's. And then I think it's pretty easy to tell whether you're on the positive or negative x-axis, right? Reference angles, any angle whose terminal side is on the positive x-axis has a reference angle of 0. Reference angles that have pi over 2 as their reference angle. So this is mistyped. This should be right here. Totally mistyped. Could have been very confusing. Reference angles that have 0 as their reference angle are all the even number pi's, whether positive or negative. Huge mistype there. You can see that it's mistyped down here as well. Terminal sides that are on the negative x-axis are all the pi's, all the odd number pi's, just like I was referring to up there. It's almost like these are kind of out of order, but it's his. But it's his order is what I should say. But this should say that have pi as their reference angle. Huge mistype there. So if you have a negative angle, a negative pi angle, so no number underneath. So if you have negative 7 pi, where is that? Absolutely right here. So is 7 pi. It has nothing to do with the negative. Let me take that off. I misspoke there. If you have an odd number of pi's, then you're absolutely on the negative x-axis and your reference angle is pi. If you have an even number of pi's, whether positive or negative, right, then you have 0 as your reference angle. So hopefully that helps. I'm super glad I went over these notes because we saw some mistypes in there that could have caused some confusion. So hopefully that helps. And I'll continue